let me tell you about what happened in March 2011 in Fukushima, Japan.
A chain of catastrophic events, an earthquake and a tsunami, destroyed the nuclear reactors in the Fukushima Daiichi nuclear power plant and caused an explosion, releasing radioactive chemicals into the air and sea.
In 2018, I was given the opportunity to visit the disaster site. I was told nobody died due to radiation, but the rich fishing industry did. And what I've seen there, other than ghost towns, were also ghost ships, abandoned, as if radiation was a vicious ghost.
Despite the Sustainable Development Goals established by the United Nations for our responsible consumption and production, there is still a threat that lurks in the ocean in the form of ionizing radiation from the dumped nuclear waste.
From the Philippine Science High School SOCCSKSARGEN Region Campus,
I'm Rebekah, Hormigos. I am Bianca, Jocson.
and I'm Kristofer, Sano, and we are Team Paraiso.
And today, we will be presenting our invention entitled
The Armadav.
How did one nuclear fallout lead to so much damage and fear?
You see, ionizing radiation is a form of energy which may lead to an alteration of genetic structure and eventual harm to the body, such as cancer, tissue damage, or in worst cases, even death.
When the fallout occurred last 2011, the nuclear wastes were released into the Pacific Ocean, which means that the nuclear waste could have spread to different areas. And with over 2.2 million species living in the water contributing to global diversity, it is crucial that we know the radiation conditions of the marine environment.
However, when we look into this issue, there is no clear picture on the radiation levels present in the waters.
In addition, there are a total of 460 operating nuclear power plants in the world, and the majority of these plants are located near bodies of water such as lakes, rivers, and seas. According to maps prepared by the World Association of Nuclear Operators, around 25% of these nuclear reactors are situated on coastlines. Thus, it is highly necessary to monitor these bodies of water for possible radiation leak.
This brings us to the development of Armadav, an autonomous aquatic radiation monitoring system that can measure the amount of radiation in an area through self-maneuvering towards the area while recording radiation data along its path towards the area. With this, proper interventions can be given when any body of water is radiation contaminated.
With this, we can now monitor radiation data in the ocean without the need for manpower. But with all these features, you might ask, how does it work?
The Armadav is basically programmed to go to GPS coordinates in the water while simultaneously detecting and logging radiation data. The data collected by Armadav can be uploaded to the safecast.org online database, which can then be viewed by the public.
In producing the Armadav, the cost is as low as $700 US, making it a viable solution monitoring radiation in the ocean.
Based on our patent searches, specifically in PatentScope and Google Patents, the Armadav is the first autonomous radiation monitoring aquatic vehicle, and the 3 trials have shown that Armadav is a promising device.
All in all, the mass production of the Armadav will serve as a great help to organizations, manufacturing companies, and other countries that are concerned with monitoring radiation levels in marine biomes, as the Armadav provides a relatively cheap way to measure radiation levels when compared to non-autonomous methods.
9 years have passed since the Fukushima nuclear accident.
9 years have passed, yet we still do not have a clear picture of nuclear radiation in the oceans.
9 years have passed.
And now, it is time for us, future scientists of the world, to take little steps in making the world a better place. With innovative solutions such as the Armadav, we can change the future of our Mother Nature.